Great. Thank you, Ben. Thank you, everyone, for staying here on a cold, cold night when it's so hard to park around here. So this is the same talk I gave at PyData in December. So sorry if you were there, but hopefully we improvise something new today. I will give the talk here, but I also put Alman's name here. He was supposed to give the talk with me at PyData. So I will introduce him first. He is he's the head of our centralized data science and AI function at Vertex. Our team is about 8 plus, close to 9 years old. So we'll tell you more about what we do, how we work with the business across Vertex. He is a great source of network if you have a chance to talk to him, with very impressive experience. So a little bit about me. I'm working on the clinical data science area. So I lead data scientists, data engineers, and software engineers, and our ops experts to create high-impact data science solution. Today's talk is structured into 2 parts. The part 1 is about just introduction of our team, so the Vertex Corporate Data Science AI function, and talk about our journey using data science AI for clinical trial operations. And then part 2 is the specific information about the informed consent form solution we built recently using LLM Gen AI. So some lessons learned on how we build it, and maybe it's useful for your own adventure at your own company. So Vertex Data Strategy and Solutions team. So that's our corporate data science AI function. We work as a SWAT team across the company. We want to work on the most highly prioritized, endorsed projects from our leadership. We have really committed business partners across the company who want to work with us, partner with us, and the business and us share the accountability and ownership of the project. And our team, like I said, we have a lot of data scientists, data engineers, software engineers, and MBAs, so ops experts. Together, we build impactful solutions and want to harness all the power of data and now Gen AI and all kinds of machine learning and AI tools to bring insights, prediction, useful output for teams across the company. And then, of course, we highly value data restriction and ethics along the way. What I want to tell you more today is actually about the clinical trial area and how, healthcare specifically, how we leverage data to help our business function. Before I go into that, I just want to say, because our centralized team work across the company, we have a lot of what you call verticals. So, my team and a lot of folks work with me. We work on the clinical trial area. So anything after a molecule or asset going to the clinic, or even preclinical analysis. So from here, the patient has to, go into clinical trials. We have to really run the trial effectively, hopefully bring the medicine to the patients faster. And then we have other vertical in our team who are focused on commercial strategy. So early commercial, once the trial is successful, how do we think about where we deploy our field force, where are our patients and physicians, and how we use data to make the prediction and analytics about that. And then in addition to that, we have manufacturing focus, human resource focus, talent focus, all kinds of expert verticals across the company that our teams focus on. So clinical trial operation is one big area we have been working on since 2019. So starting, with the business team, really help them understand what we can do with the real world data we have in-house and externally, public data, private data, and show them what kind of data asset we can build, help them envision the solution that can be useful to their operational workflow. So a lot of test and learn in the early years. And then going to several years into that collaboration relationship, we have a lot of great early wins. Solutions become more standardized. We like showed people what are essentially the menu of capabilities we can build to help the clinical operation teams, and then along the way we measure a lot of impact. So those impact story also encourage the business to have more trust in us, in working with us, and then those momentum keep building itself, and we have a lot of increased demand in that time. And now looking into like the recent years, we are in a very much standardized kind of process with the business team, where our solutions are much more standardized, applied to all disease area, all pipeline areas Vertex is working on, and we are trying new LLM, Gen AI based solutions, and trying to have the great momentum from the past year keep going, and also create new impact along the way. So you can call that a flywheel effect. Our hope is maximize the business impact for the teams. So what it means actually for helping with clinical trial operations, I can illustrate that with a few questions here. And essentially, we first of all have to build very useful data assets that's mostly built off real world data. So you can imagine large scale claims data, insurance claims, electronic medical records of patients of various conditions and diseases. So for each of our indication, our question will be like, where are our potential patient population? Are they diagnosed? Are they underdiagnosed? Can we create a model to help them find the clinical signal that indicate their true diagnosis? And then related to that, who are the physicians treating them, where they are located in the US or in the world? So all kinds of business operational questions can actually be answered and helped with analytics using large-scale data and also machine learning models on predicting how we can guide them to go down the right decision, to go to the right areas for the patients and physicians. And all those hopefully help us to bring the medicine faster to the patients in need. And I want to give you two examples of the projects we do. So we categorize them more clearly in analytical AI and Gen AI categories. So analytical AI, I will say those maybe you're most familiar with are machine learning model empowered, so predicting which site will be the most successful enrolling certain patients, forecasting and predicting Bayesian model of how fast the trial will enroll patients, a certain event will happen. So those are analytical AI projects on clinical trial operational area. And then on the more newer vertical, the Gen AI, you can imagine could be a lot of document auto drafting. We can have a lot of translation enabled by LLM, and then create brand copies using input information from marketing team. So those are examples for Gen AI projects. And I want to give you more examples on each of the areas. So for analytical AI, I want to introduce you to the structure of how our projects go from fundamental data sets to all the way to impact. As I mentioned, we have a lot of real world data, which means from designing of a clinical trial protocol, we can use data to guide the optimization of design. And then from there, we can create a lot of automated pipeline to help us create HCP lists, so physician lists, and also help us identify what are the sites with the best metrics that we want to work with. And from all those metrics and data set and lists, you can imagine a lot more interesting analytics can be done on the top layer. So it's where our highest impact could be. So from there, we can use the site metrics we already know to predict which one could perform really good in our upcoming new trial. And then for enrollment prediction, also using the past data to kind of project the new performance. So as you can see, we're building these solutions going from fundamental data on the bottom as our foundation of the team, and then building more metrics, creating the metrics, having standardized data that everyone can refer to, and then on top is the prediction, the actual impact we can capture. So building those takes definitely multiple years of just collaboration and continue working on patients with the multiple business team we work with. And similarly for Gen AI solution, maybe it has a very similar structure but different content, because the fundamental part on the bottom will be the documents we actually are rich in information we want to leverage. So it could be embed them to retrieve certain information in the document, or generate summary from them, or create new documents using those fundamental documents. So in this case, for clinical trial, it's the clinical trial protocols. So you can imagine maybe other key document that a lot of downstream documents are based from. So from those protocol information, the information we can extract from the protocol, we build this automated and LLM-based and information extractor to extract all the information and processing them. We also, on top of that, have a user interface to trigger the generation of additional documents based on the protocol source. And then so on top, you can see actually that's the user solution where we build a informed consent form auto-drafter and set budget auto-drafter, and also many other clinical trial documents that we'll need for making a clinical trial happen. So maybe you're not familiar with all the clinical trial space, but maybe, well, I guess you can imagine maybe you go to a hospital, how many documents maybe you have to fill in ahead of time, and generating those consent forms, sign this and that, and a lot of maybe the lab results you read from your clinical visit. So many documents actually are generated alongside the care delivery system, so especially true for clinical trial operation. So this whole ecosystem of solutions really help our team save time, hopefully help them increase the precision of the document generated, and eventually help them work faster and smarter. And overall, based on our learnings of all the document generation experience, we are thinking like just doing individual document generation is really highly inefficient. In reality, our team really learned about how each documents connect to each other, and then built a map, essentially a network. Imagine like how the Park Street connects to all the different red line, green line for the Boston T system, even though it's not working well. But imagine if it's working really well. There are center stations that linking so many other stations and lines. So to us, the clinical trial protocol is like a key station that links to many related documents along the way. So building this network and building the toolkits and protocol parsers and generator that leverages synergy is very important for us to kind of scale up the solution and scale up the time saving we can get from leveraging the Gen AI solution. Okay, so what I want to say, maybe this is a really complex slide, but essentially you just need to probably understand that for a clinical trial, it needs to be designed. The study needs to be designed, and we have to plan it to happen, and then make it happen, execute the trial. So along the way, our hope is we build standardized solution for each component of that step, right? We'll have optimization protocol, optimization for the protocol using Gen AI to understanding the protocol, using real-world data to recommend changes to improve the patient recruitment, and we also have data to help the site selection. We have trial forecasting to help understanding how soon the trial will end and finish enrolling. And along the way during the execution, the Gen AI solution we built will help creating the documents faster and more accurate. So as you can see, our team has been trying to leverage traditional machine learning and AI to across the entire life cycle of the trial operations. And very important part our team probably differentiates and stand out is how we keep the impact measurement and whether we think about we are working on the most important project really on top of our mind. So every single project we try to define a way to quantify whether we make the difference. Is it money saving, time saving, patient recruitment improvement? So we try to always make sure we're measuring something that's meaningful for us. Okay, I think Ben only gave me 30 minutes, so I'll try to tell you more about the ICF specific project in this time frame. So after all the setting of our team and how we're doing different projects and clinical trials, this is a very important project I want to highlight. It's how we create the ICF auto drafters, so informed consent forms using Gen AI and large language models. I'll skip this, you all know about it. But this is more the context about clinical trial informed consent forms is essentially a document a patient should read, probably in detail, to understand what it means to go on a clinical trial, what's the risks, what's the criteria, and how many visits they have to go to the hospital for enrolling. So it's important for the pharma as a representation from our image to the patients, but they're also important for the patient to participate in the trial, and really also needs to be regulatory compliant to get approval in each of the site and country across the world. So as you can see, a very important document, but drafting of it is very manual. It's about like 10 to 20 pages, lots of information, just you have to read it from the protocol and manually enter it, and the whole process quite time consuming and just not an efficient method previously. And luckily, the team, this is the global startup team who work with all the sites in the trial across the world, right? They help the site get ready for the trial. So they approach us, and we have an amazing collaboration for the past maybe a year and a half, almost 2 years, that together we build a solution that essentially read the protocol, comprehend all the important sections of what patients should do, physicians should do on the trial, and then use those information to create this informed consent form that's highly structured and informative, and output this document for the global startup team to review and finalize. So a very powerful solution, but conceptually very simple. So under the hood, it's about, we use all Python toolkits and custom modules and build all those steps to retrieve the information, parse the document. We use section-based chunking, and now also trying a lot of agentic traversal chunking. So a lot of different ways to find the relevant information from the protocol. And then, also have a lot of bespoke prompts to make sure our information we retrieve from the protocol is the most relevant for the business team. So all those technical aspects we wrap together and host it in the AWS app, and with the front end to enable the business team essentially go in and upload the protocol that they need to generate document from. After about 5 minutes of processing, tagging, chunking, and then retrieving the information, the document is generated in the Word format and allow the user to download. So all those information is returned to the user, and they can start editing using their standardized workflow to finalize the document. So across all this journey, I think what we value at Vertex is really about, are we thinking about what's the right part of the workflow that we should solve using Gen AI? So it's not entirely workflow has to be AI enabled, or of course we shouldn't do all manual workflow that's really highly efficient. But can we find a part in the workflow that we can expedite? So we have the AI in the human loop that we can reduce the risk and also improve the efficiency gain at the end of the day. So that's what the pilot of AI solution look like in Vertex. And along the way, we do have a lot of lessons learned, and a couple of them I want to highlight is definitely we always want to measure impact. I think a lot of especially for the early days of a solution, that we need to get more business buy-in. At this stage, I think a lot of businesses are very enthusiastic about Gen AI LLM-based solutions. So maybe you don't have to do as much selling or convincing, but from the early days, like the 2022, 2023, you definitely need to do that measuring impact and piloting the most important part of the project. Maybe something to get the business start believing and have the momentum to keep building interesting things. And then the second part, very important actually, is about change management. I don't know whether you talk about it a lot, but that's something we always needs to do, because Gen AI is a new workflow, right? Some of the interaction, even the UI we built, is intuitive, but it's a novel workflow, new document, some new mechanism the team doesn't really know how to interface with. So we have to design the solution with them together to make sure, what the Gen AI output, the auto-generated parts are actually well labeled, visually, obvious. So the change management actually happen from the day one of when we build the solution together, all the way to giving them the training and change the documents of the official workflow. So it does have a lot of details built in there. And it's not just something you do at the end. So thankfully we have a ops expert, we have PMs, we have teams who are familiar with the business process to help us think that from day one. So do that from day one if you are having a solution that you want people actually use it. The third one is about scaling up. So I talk about the ICF auto drafter, but we actually, from there, in order to scale up the time saving, because just one document, you can imagine, maybe we save an hour or two, but we didn't spend a lot of hours building that tool. So to harvest actually the impact and actually generate more transformational impact, we think we need to do that for probably more documents, a lot more, leverage the same synergy of the protocols. So from there, we are building a lot of other auto drafters in the same clinical operations space. And then hopefully each of them, we gain more impact, and together it's a much cohesive user platform, and more users are getting benefits from it all the time. So we're building that, and then the business teams are really patient with us. So that's we feel very lucky for the continuous collaboration. Okay, so I think maybe this one is worth a little bit more talking about, because this is about the measuring impact. What make our team really special is how we think about more like a scientist, or how we can we do an experiment. But because we have real people doing that, we have to think about design and how many times we can actually do it. So in order to compare whether the auto drafter saves time, so we have to have essentially doing double duty for the same protocol. We auto draft it using our tool, so it takes less than 10 minutes, and also having someone from the team who do the work to manually draft it. And oftentimes it's a protocol, a study already happened, so they're just doing duplicated work to help us do the experiment, which is still very important, and we are really grateful they are supportive and are collaborative to do it together. So we'll have the side-by-side comparison of auto drafter compared to a person manually drafted across multiple studies, and understand what's the time saving for that. And from there, from a partially filled templates, we also want to mimic how long does it take for them to finish editing and then finish the QC to complete the final document, and have that as an end-to-end time saving. So together we observe initial drafting, of course we do it really fast, 90%. But when we're considering the editing and QC, it can go down to 40%. It's still a decent amount of time saving, but because the novelty of the visual, of the output of documents, and because it's auto drafted and not manually done by them, they definitely take a little bit more time to actually read and QC it a lot more. But at the end, still a substantial time saving overall on the workflow. So scaling up is what we're doing now and continue doing. And this is actually what the UI looks like, about someone going there to upload documents, select the different document they want to generate, answer a couple user-specific questions, and then generate the document download. And scaling up, as I mentioned, is about how we leverage the same central document that links many downstream network of documents to create this auto drafting capability across hopefully entire organization. And then we're doing that too for medical space. So this is clinical trial space, and we're also doing for medical space, and then regulatory space, and also hopefully commercial space. So you can imagine similar tools and synergies can really increase the efficiency of document generation across the company in different domains. Okay, so that's all. Thank you for being patient, and you seem interested in the topic, so thank you.
Thanks so much. All right, good for questions?
Yeah.
Great work. Considering the amount of time that goes into drafting these documents. 2 questions. Did you have a specific LLM that you used for some of this clinical terminology?
Mm-hmm.
And from a QC perspective, how do you go about QCing these documents? Does it go through the process, or is it manually done by one user at a time?
Yeah, very good question. We don't have a specific clinical LLM, but that could be a really good, idea. But we use GPT, so OpenAI enterprise model. Hallucination, we do have kind of LLM checking the hallucination on itself using a separate workflow. From there, if it doesn't pass the confidence score, we exclude it. And currently, we also have a more Bayesian approach model based on all the data we generate and benchmarked. So we have a manual way of generating a benchmark data to compare how good we are on all the documents we generated. So using the data to kind of adjust the confidence score of LLMs self-guessing. And after all those, hallucination checker and QC checker we have, the business team is actually the oversight, the final step. They have to approve and double check everything is accurate, so put on their stamp. And that is probably our best bet on producing the really good document for the patients. Yeah.
Very great talk. I have 2 questions. Number 1 is that the clinical trial normally have a lot of variations. So you seems like it's kind of standardized. There's a couple cases maybe like some cases couldn't cover by your thing. In that regard, how you deal with that? Second question is that when you present this AI solution to the regulatory team, for example, like compliance, what's their concerns about data privacy or something else? I mean, how you deal with that? Thank you.
Yeah, I will answer the second question. So no patient data enters this, right? No personal information enters this. The regulatory agency who review this document for patients are also relatively open-minded about, if you have a tool of auto-drafting a document for us to review, that's cool. Nice, thanks for telling us. We'll learn and see how the quality is, because they have to review it manually too. They probably have their internal AI tool to help review it. Who knows? So the first question, there's a lot of variability of the trial actually design. We deal with mostly single cohort trial here. Yeah, and then for multi-cohort, actually for informed consent form, the drafting is not too complex. But we are actually dealing with multi-cohort or more complex design for example, site budget drafting. So I don't know. I don't know whether you know site budget, but from a trial, will be a very complicated budget design for each of the sites, for each of the country to actually agree on with us. So all those documents are actually very sensitive to the multi-cohort design and how many times the patient visits. So that we actually build more multi-cohort function. We build functions to read amendment change. Like if the protocol went through 10 amendments, then we should know what was being changed and show the most informative data for the site to understand the budget change. So that's some examples, but I know we can't catch all of the differences, but we try to maybe catch the most.
Okay.
Yeah, but the impact measurement is very important because we will talk with the business very frankly. Like, do you want us to build it? It might not have a high ROI, or are there more important things you actually want us to make together? So maybe we should prioritize that first.
Lily, I have a question.
Uh-huh.
Something special happened in December when suddenly openness was the craze, and now you can build anything you want. How do you think that will change team dynamics within Vertex?
That's very cool. I do want you to show us what you built. You know, Eric was just showing me something really cool before my talk. I think that hopefully will help us prototype or bring things to the business faster. Because right now it's still maybe the more traditional software engineering approach, even though people have all the cloud code to help them code, but we still take us maybe 4 sprints to bring a useful feature, right? We have to do a lot of testing and to make sure the QC is right. So I hope, you know, it will really help us to bring the ideas you have in your head faster to someone's hand and then iterate from there.
Yes. First off, since you said you use all the Python libraries for all the document processing, have you ever tried Docklin? If not, that might be something fun to look into because it's an open source library from IBM. They have a couple of open weights models to go with it, and it's just a structured document extraction. So that would be something.
Yes, we actually learned about that at the PyData Boston in December. So yeah, I think it's definitely a very, very cool, you know, option to use.
Should go to PyData Boston next year as well.
Yeah.
Right. So here's the question, which is that what I've understood you're doing, this is partly an assumption, which is that I assume that consent forms and all the other documents that go into it are fairly highly structured. Like there's a lot of standardization on how that document should look like. So no matter which country you are, standards differ, but it's ultimately a very structured thing.
Yeah.
And so what you're trying to do is you're trying to find information in a structured document and move that from one document to another document, and that's sort of the auto generation. Can you talk a bit about like the evaluation that happens in that step? Do you use evals? How do they look like? Do you use like human in the loop there somewhere to like annotate data, create a gold data set or something along those lines? How does that process look?
Yeah, I would say the protocol to the forms are relatively standardized. The protocol though is actually not. Maybe it's us, maybe it's industry wide, but the protocol writing can be very free, you know, free-spirited. The information will be there, but it might be sprinkled or reformatted in different ways. So that make it hard. What we do, I think we, across like a dozen protocols we manually create a benchmarking data to monitor the quality of the drift from our LLM queries. And then using that as our maybe baseline and monitoring going forward. But human in the loop, I will say it's our human oversight because we are only generating the first draft. And then downstream process is all completed by our teams and cross-functional teams. So that's why we call it AI in the human loop. It's not like human in the AI loop. It's like actually majority is done by human and verified by human. So I think relatively low risk for making that to triage that. And we also have a very interesting solution actually of our GCO, Global Clinical Operational Document Auto Drafter, because when we allow the business team to upload the protocol, we digitize all the interesting field extracted from the protocol, and then because we have the Bayesian adjusted confidence, we let users to go in and verify the low confidence score. So we kind of know like across what threshold low confidence we need human verify. So they actually go in, verify like is this information correct from the retrieval, and then use those verified QC document to generate all the downstream documents. So I think all the drafter doesn't have that because we build that so early, but all the downstream other documents we build in this big domain space have that QC step that hopefully we can catch even more hallucination if it happens. Yeah. I almost forgot about that.
We'll probably take one quick question.
Thanks so much, Dr. Zhu, for the wonderful presentation. I have a question, and that kind of circles back to the question from the previous speaker. So, if you do have human in the loop, so at present, what would you say is the accuracy of the auto drafter that is generated by your LLM?
I would say, I would say it's good. So we measure consistency where we just simulate the run 100 times on the same protocol that we know the benchmarking data, and then say how text similarity is between the truth and between each of the run. So that's good. Also, we have up to 13 protocols now with all the real benchmarking data. So we compare human generated versus machine generated, how similar they are, and then how accurate they are across the protocols. Maybe it will drift, maybe it will improve as we go, but we value those experiments in a great deal. So those help us understand accuracy. What Griffin talked about, the more information you provide, the more dilution, the more difficult to do it. We definitely see that when the protocol is written in a very free-formed, maybe the same information occurs in different sections, and it's hard to process, give the right chunks to the prompt, and then it's really hard to generate some part of the informed consent form. So we are not able to get to 100%, but I think that the business team is very understanding, because we give them training on what's the risk, what is somewhere it does well, what some other place actually doesn't do well. So you should prioritize QC when you're reviewing the document. So the business team are very well synced with us on how to take advantage of the output, and then hopefully reduce the risks out of it too.
I have just one more question as a follow-up. So if you talk about the business model where the volume of the documents that is being done, so at present I understand that they are primarily handled by humans at every step, passing through multiple checks or AI models actually from one system to other. How sustainable do you think it is in the long run, where the volume of documents increases, and do you think in the near future that there will be any human at all managing this process, or do you think AI usurping the role of humans even for the validation aspect?
No, I don't think it's that feasible to have the LLM to validate. So yeah, I think there's still a lot has to be done by the human, the knowledge, the conversation people have. Maybe you can argue that those all can be done by agents, but I don't see it happening very soon, honestly.